Now we shall see the new problem on belt drives. So here in this problem they are asking us to design the belt drives. So this problem is slightly different from previous problems. We shall see how to solve this. A horizontal drive is required to drive a compressor by means of an electric motor. So here electric motor is the driver and compressor is the driven. So here they are telling that the compressor has to be driven by electric motor. Select a suitable flat belt drive from the following details. Data given is power 6 kilowatt, slip is equal to 2.5%, speed of motor pulley 1400 rpm, service factor 1.2, working stress sigma is equal to 2 MPa, joint efficiency 90%, and speed of compressor is equal to 500 rpm. So initially we shall write the data given. Power is equal to 6 kilowatt. Slip, we shall call this symbol for slip 2.5%. Speed of motor, here the motor is the driver, so we shall consider ns, because driver usually it will be smaller and driven will be usually larger. 1400 rpm. Service factor, we shall call it as CS. CS is equal to 1.2. Working stress sigma D or simply sigma 2 MPa. Joint efficiency. Joint efficiency we shall call it as efficiency J. So this is efficiency, this symbol is. So we have given suffix as J. It is 90%. Speed of compressor N. So compressor is larger pulley NL 500 rpm. So we have to design the entire belt drives. So the preliminary assumptions we shall make it. Preliminary assumptions. So the preliminary assumptions is assume that the pulley is made up of cast iron. The next assumption is the service factor they are given as 1.0. So the design power, that is for design considerations we need to take the power as CD. It is nothing but the power into service factor CS. So the actual power is 6 kilowatt, but we have to design the entire belt drives for slightly higher power. So normal power into service factor. CD is equal to normal power is 6 kilowatt into service factor is 1.2. So it becomes 7.2 kilowatt. So CD it is 7.2 kilowatts. Now first we shall find the diameters of the for both driver pulley and driven pulley, and we have to find the belt thickness, belt width, everything. So first we shall find the velocity. Velocity is pi dn by 60. So here we need to take the angular velocity omega n. We need to take omega. So from data handbook we shall see page number 292. They are given the equation for diameter. Here page number 292, cast iron pulley. So this is the diameter of pulley. This is the equation. Here they have given 535 to 630 square root of cube root of power in kilowatts divided by omega max. So the value of omega max is 2 pi n max. So here the value 525 to 630. So we shall take the higher value here. 630 is the higher value, we shall take it. D is equal to 630 cube root of power divided by omega max. So omega max is 2 pi n max. Two pi n max by 60. 2 pi n max is smaller pulley 1400 divided by 60. So omega max is equal to 146.61 radians per second. So next we shall find the diameter. We shall take this formula. So this formula is given by 14.9 A, page number 292. 630 cube root of power is 7.2. So power should be substituted in terms of kilowatts divided by omega max. Omega max is 146.61. So the value of diameter we are getting as 230.71 mm. We shall take one standard table. There is one standard table and 14.13 B. Your table 14.13 B, page number 313. There is a nominal diameter of cast iron and mild steel pulleys. So we have got the diameter as 230 mm. So here there is 224, 250. So we shall take the higher value 250 mm as standard diameter. Table 14.13 B, page number 313. Next we shall find the larger diameter. So after finding smaller diameter, they are given the formula for larger diameter, the diameter of the driven pulley. D is equal to 1 minus epsilon di. This epsilon is percentage slip they are given in the question, and I is velocity ratio. This is from equation 14.9 B, page number 292. So here we shall find the I is gear ratio or velocity ratio, that is ns by nl. Ns is 1400 by nl is 500. So the value of I is 2.8. Now we shall find the diameter. 1 minus 2.5%. So 2.5 divided by 100. Into smaller diameter is 250 mm. Into I is 2.8. So the value of diameter, larger pulley diameter, we are getting as 682.5 mm. So again we shall take the standard diameter table. Nominal diameter of cast iron, the same table which we had taken for to find the standard diameter of driver. So we have got the value of 682. We shall take the next higher value 710. 710 d is equal to 710 mm. So this is the standard diameter. So we have found out the pulley diameter and both smaller diameter and bigger diameter, that is the diameter of driver and driven. Next we shall find the remaining data such as width, efficiency, thickness. Next we will find the value of belt speed, speed or velocity pi dn by 60. So this is we are finding for smaller pulley, and they are given the slip percentage 1 minus epsilon they are given. So if they are given, we shall consider slip, otherwise no need to consider. So here the diameter of smaller and speed of smaller pulley we are considering. The diameter is 250 into 10 power minus 3 into speed is 1400 divided by 60. So the value of speed velocity 1 minus 0.025. (17.87 meter per second).